Unfortunately, and as usual, interest in the alleged Giza subterranean structures has faded. But actually, the more I study the SAR rendering, the more intriguing it becomes, as it looks like some type of vibrational energy machine. I'm in the process right now of building a miniature model of it to study how sonic energy might flow through it. Particularly interesting are what look like titanic tuning forks lined up on one side of the contraption. I wanted to see how placing a large 128 Hz tuning fork in a similar upside down orientation on the model would work. But its wooden base prevented the fork from making contact with the ball. So I took a second fork and placed it right side up on the model so that it could make contact with the ball while still maintaining its vertical orientation in relationship with the contraption's energy. Activating the device and cycling through a number of frequencies causes the ball to be repelled to a greater or lesser degree, just as in past acoustic power transfer experiments with two tuning forks connected by a string or wire. A simple test, nothing groundbreaking, but it does show that a tuning fork placed in a similar vertical position as in the rendering of the alleged subterranean contraption can store, transmit, and release a significant amount of vibrational energy from the structure, converting it into a vibrational force sufficient to propel the ball. It seems that this could have been a possible function of the tuning forks as components of this subterranean curiosity, especially if it is some kind of energy harvesting device. With our modern studies into energy harvesting, we know that the energy of the majority of natural sources is intermittent. Whether it be windmills, ocean wave turbines, solar cells, piezoelectric devices implanted in sidewalks and roadways to harvest footsteps and car traffic, the energy would not be consistent in terms of intensity or quality. A capacitor or a capacitor battery combination would be needed to convert this intermittent energy into a more steady state. This is where large vibrational elements might come in. Tuning forks and gongs have the ability to sustain for long periods of time, meaning that their vibrations dissipate over a longer period of time as compared to most other objects. All objects, of course, have acoustic properties and generate tones when struck, but there is a very wide variance when it comes to their acoustic sustenance, or how quickly the tones dissipate. For instance, sharply tapping a wooden board will result in sound, but that sound decays rapidly. If video playback of the decay could be sufficiently slowed down, we'd see that it does sustain to a degree, but only for a few milliseconds. In real time, though, it just sounds like a sharp tap. However, when the huge gong shown in the clip here is lightly tapped, we hear a marked difference. Rather than rapidly decay, we hear the sound intensity increase as the energy of each tap builds upon the wave energy of the preceding taps. A vibration spectral analysis app reveals a diverse frequency range for this particular gong, which is rich in varied overtones, mostly ranging from 300 to 800 Hz, but almost all under 1000 Hz. A tuning fork has the same property of acoustic sustenance as gongs, both being essentially capacitors for vibrational energy. Even though large tuning forks and gongs possess considerable acoustic capacitance, they still have their limits. Large spaces have comparatively greater potentials to store acoustic energy. The ability to sustain sound within a space is referred to as reverberation, as opposed to sustenance, which describes the same ability within a solid object such as a tuning fork or a gong. Large open spaces can enable sound to achieve reverberation times of up to 2 minutes or more, and like tuning forks and gongs, are practically acoustic capacitors. The harder and more reflective the surface is, the better, as this prevents the sound energy from being absorbed and quickly dissipated. These parameters describe tunnel spaces perfectly. Interestingly, this structure is said to be accompanied by a vast network of interconnected tunnels. Coincidence? Microseismic energy from the Earth might persist at certain frequencies and intensities for minutes, hours, or perhaps even days, but it would eventually vary, requiring elements of vibrational capacitance in order to maintain a more consistent output. Going back to the model, I can get a visible interaction between the fork and ball at several frequencies in the range of 27 to 146 Hz, with 27, 75, and 82 Hz seemingly giving the strongest responses. Though the input frequencies are different, the fork vibrates at its own steady resonant frequency. This can be better understood with the following example using a 440 Hz tuning fork. I could apply an electromechanical signal to the fork at its exact 440 Hz frequency, or I can also just give it a singular sharp thump every few seconds. Thumping it once every 4 seconds is equivalent to a frequency of 0.25 Hz or 250 millihertz. I could then bring up the thump frequency to once every second or 1 Hz, or even lower it to once every 10 seconds or 0.1 Hz. Either way, the tuning fork maintains its own steady frequency of 440 Hz with relatively smooth energy levels. Theoretically, a steady frequency might be desirable as it would allow spaces such as the king's chamber or even individual blocks of stone to be created with the necessary dimensions to resonate within predetermined frequency ranges. This would result in optimal acoustic energy transfer and accumulation at the Earth's surface. With these principles in mind, it is feasible that the massive tuning forks of the hypothesized megastructure function to convert the incoming microseismic energy into a steady frequency state, which would simply be their own natural resonant frequency. The vibrations would then radiate into the capacious cavern housing the contraption, where they would create very long standing waves. The tremendous energy would be stored in this acoustic field, just as the energy of a capacitor is stored in its electric field. The extensive tunnel network would store energy as well, but could also transmit it to the surface to be utilized for various purposes. The energy could be released as a lower intensity steady stream, say for vibrational therapy, or it could be released in quick, powerful jolts to shove massive building stones or drill into and carve hard stones. I will attempt to demonstrate these proposed principles of energy conduction and utilization with a model in an upcoming video. Another interesting fact about microseismic energy is given that it ultimately originates in the ocean, and so it follows that the sun and moon exert indirect influences on its intensity and vibrational frequency ranges because of the tides that they create in the ocean via their gravitational influences. Hence, it would be highly advantageous to be able to understand these influences, as it would enable one to in turn predict and chart when such a system would be at peak operational capacity. Perhaps this could be an additional reason why the ancients were seemingly so obsessed with understanding the movements and alignments of the sun, moon, and planets, as well as other major celestial events. Imagine the power to move mountains of stone and fashion them into eternal edifices erected to touch the heavens, a power originating from music generated deep within the earth and fine-tuned by the celestial fingers of the sun and moon. It's nothing short of poetic. As unbelievable as a machine which converts seismic energy into more usable forms, especially one of ancient origin, might sound, we must keep in mind that we are attempting to do this very same thing today in our own searches for alternative and renewable energy sources. Microseisms are among the many ambient energy sources that we're attempting to harvest. But scientists might not be going about harvesting this potential energy source in the best way. Current approaches involve very small harvesters, usually tiny piezoelectric devices, presumably because the intensity of the microseismic energy is relatively faint at the Earth's surface. However, the very low frequency bands in which this microseismic energy manifests would imply that receiver devices proportional to those larger wavelengths might be more efficient. Given that the wavelengths of microseisms are thousands of meters long, it follows that components of a similar size range, or at least a significant fraction of it, would be ideal. It also follows that such devices should be embedded deeply in the Earth's surface in order to be as close to the source of the vibrations as possible. Perhaps it shouldn't be surprising then that both of these characteristics describe the alleged megastructures perfectly. If the Khafre megastructure was indeed used as a power source in distant antiquity to enable the ancients to accomplish great feats of engineering, then it's unlikely to be the only one of its kind. Perhaps there are several such megastructures buried all over the world. One of the interesting things about vibrational energy is that it can be easily coupled to other vibrational energy fields of the correct phase and frequency, linking the source devices together wirelessly. If this sounds familiar, it should, as it essentially describes not only the concept of an interconnected world energy grid, but also Nikola Tesla's wireless world power system, but in vibrational form rather than electrical. Contrary to popular conceptualization, Tesla's system would not have consisted only of the one tower, but rather a number of towers placed on energy antinodes around the Earth, each deriving energy from the Earth through resonance and connecting to each other energetically, creating an integrated regenerative system in which power could be accessed at various key points across the planet. Many alternative investigators have theorized that some kind of acoustic technology existed in the distant past, which was used to move and process huge blocks of stone. Some, more conservative researchers, also question the accepted consensus and ponder if the ancients had access to some form of external energy to multiply their efforts, just as we do today. But there was always the nagging question as to where they would have derived this energy and how it would have been distributed. Perhaps this strange contraption and this accompanying network of tunnels and shafts could help to answer that question. More experiments will be forthcoming. Thanks for watching, and as always, stay tuned.